My dear students, Assalamu alaikum and Namaskar to you. I hope in the present coronavirus crisis you are well. Let Allah keep you safe from the present crisis. Our subject title is Design of Concrete Structures 1. From university's website and my course content, you will get whole description of the course. I know that you had this same course in your diploma studies. I am Professor A.P. Abdurrauf. I graduated from Asarul Engineering College in 1959. I got my MSc degree from Texas A&M in 1962. I worked in Asarul Engineering College as a lecturer and later on Bangladesh University of Engineering and Technology as assistant professor and professor like that. And I retired from that institute in 2003. And after 1 year of rest, I joined World University of Bangladesh in 2004. Until now, then I am working as professor of civil engineering department, and an advisor of the department and dean of faculty of science and engineering. Now I will be talking about your subject 703. And I will follow concrete structures by Nielsen, 15th edition. So you must procure the book as early as possible. It is further suggested that you keep the book in your personal documentation file. You can collect the PDF format from website. Now I will talk about the subject itself. As we will be dealing with concrete structure, in this structure we will be dealing with two materials. One is concrete and another is reinforcement. Among reinforcement will be given will be the steel material. So here is some description of these two materials and qualities, quantities and the other properties of these written in a paragraph, and we will be discussing this slightly gradually. Concrete is a stone-like material obtained by permitting a carefully proportioned mixture of cement, sand and gravel or other coarse aggregate and water to harden in forms of the shape and dimensions of the desired structure. You know that these are the materials which make concrete. This is aggregate, sand, coarse aggregate, fine aggregates, cement and water. These are the four ingredients which make cement concrete. And the cement with water is chemically reacted and becomes hardened and surrounds the aggregates and makes a mass of concrete. And so we must choose these aggregates very strong, then you will be getting a stronger aggregate, a stronger concrete, and good quality cement, and you will be getting good quality of concrete. That should be our aim and we should look for it. The properties depend on the substantial degree in the proportion. When a proportion, we must learn proportion of mix to get better strength of concrete and mix design in engineering materials. So you have read that course earlier in diploma, and you will be reading this course in this university also when we will go to other higher semesters. Whatever it may be, you will be knowing all details of concrete and all elements which make good concrete. And nowadays very high strength concretes are made for high-rise buildings. Therefore, there are special materials like plasticizers, air entraining agents, silica fume and fly ash, etc. These special curing methods like steam curing permit even a better quality of the material. These properties depend to a very substantial degree on the proportion of the mix, on the thoroughness with which the various constituents are intermixed. Whatever it may be, the whole thing should be in a very controlled way, very measured way. The concrete should be made so that every part is given in a proper proportion, and every step is done properly and take carefully. That's all we will be making concrete. Then next, you know that concrete is weak in tension. That's why we will mix with concrete steel materials to take care of the tensile forces, and those steel materials and reinforcements will be placed where the tension will be coming up in this structure. And steel materials are very high strength materials, and they are good in tension and also good in compression. But we will use the compression forces we will take care of the compression forces by concrete properties, and we will try to take care of the tensile forces by the use of steel. But steel can also take compression. So when we will need smaller sections, we will use steel in the both compression zone and tension zone. And steel, we have very high strength steel nowadays, starting from 60 to upper 1, and so we will be taking advantage for these two materials. Simultaneously, they will combine together, and will make one member, and they will act in such a way that whenever we in tension zone, the steel will help. In compression zone, the concrete will help, and if we put some steel in the compression zone, that will also come into action to take care of compression. So these two materials ultimately using as we need, wherever we need, we will be using both of this material to take care of the forces and stresses like tension and compression. And the steel material is costly, but the area requirement is smaller than concrete. So the whole structure becomes not so much costly. So we will try to use steel, and we must know the properties of steel a little bit. In designing any member, we must know the loads. What load will be coming in this structure, and there are load tables in the book. The author has given a long list of loads for designing the different structures, and I have chosen some of the important loads from that table. You can go through the original table in the books and see there are many items and many details of the load calculation, but I have picked up some of the major and important types of load with which we will be designing structures. Normally the load will be naturally, first of all, will be coming to the slab, and from the slab it will go to the beam and also to the column to foundation. Whatever it may be, a list is provided here from where you can get normal loads for common situations. And this is given in table 1.1. 1.1. There are 2 pages, and you can pick it up. Now we will go. Design basis. Previously, when we were designing and working stress system, their stresses were taken at a lower rate, lower value, and loads were given the exact load, and the calculation for the moment and shear was the calculation of moment and shear was the base of original load, on the basis of original load. Nowadays, the system has been changed to design of a stand design. Stand design means we will be increasing the load to give a factor of safety, but we will use the ultimate load of the materials. Previously, they were the strength of the material was taken as part of the final crushing strength or tensile strength or crushing strength of concrete and tensile strength of steel. Nowadays, we go for the ultimate load, ultimate capacity of the material, ultimate capacity of concrete and ultimate capacity of steel. But as we go for higher steel rates, we have to use the factor material, that is the load should be increased to give the to give factor of safety. We increase the load and we take the full strength of the materials. Load by increasing the load from the actual load, we give the factor of safety there. And in this way we design, and this is known as a strength design. Strength means the full strength design. We use full strength of concrete and full strength of the steel material, reinforcing material, and from the probable load we increase it by some factors depending on the nature of the load, like live load, dead load, wind load, earthquake load, etc. For each of these loads have different factors. Like live load is given a factor of 1.6, dead load is given a factor of 1.2, and wind load, etc. are different factors above 1. And in this way we increase the load to get the increase the load value from the actual load to get the factor of safety in the structure. In table 1.1, the actual values, exact 1.2, the exact values of the load factors, the load effect, I mean with what value of the increasing of the load, how much load will be increased for dead load and how much for live load. In the table it says that it's written that for dead load you have to multiply it by 1.2 and live load you have to multiply it by 1.6. And if you have only dead load, then you have to multiply it by 1.4, and like that the other loads are given here for live load, dead load, wind load, and snow load, etc., etc. In normal practices in our country and in this course, we will be mostly use the dead load and live load only. We will not bring out the earthquake load or wind load, because at this stage we have not learned about those magnitudes. Therefore, we will be depending on, we will be limited to 1.2 and 1.6 live dead load and 1.6 live load only. Another thing is shown in this page 10, that there are different types of failure, like tension failure, like compression failure, like shear failure, like bearing failure. These sort of failures will be coming in these structures, and depending on the type of failure, the SI code has suggested different factors to be reduced, the capacity to be reduced by these factors, and the factors are listed in table 1.3. Okay, for example, for tension control sections is 0.9, that means in bending moment we will be using 0.9 as a factor. For compression control sections like shear, we will be using the factor as 0.75 reduction factor, and for bearing, etc., we will be using 0.65 as the reduction factor. So depending on the nature of failure, they have adopted a factor of safety, because type of failure in tension and type of failure in shear and type of failure in bearing is quite different one from another. That's why they have given, depending on situation, in bending moment they have given bending tension and compression in both cases they have given 9, and in bearing they have given 0.65, and shear they have given a 0.75 factor these are the reduction factors, strength, whatever strength we will be getting from the dimension and the other properties of the material. You have to reduce these values by these factors. And while we will be working in problems and designs, we will refer to these factors and use it properly. For this course, we will be following. For this course, we will be following Design of Concrete Structures by Nielsen, Darwin, and Dolan, and it is 15th edition. Possibly it's 15th edition. No earlier edition will do, because the 15th edition you will be it is available in the market and is cheap. Only 150 or 150 taka will be sufficient for purchasing a book. So you should purchase a book for yourself to keep it for this course, and we will be following this book in 2-3 courses, 4 courses. Even in the final year also we will be following the Nielsen's book for some courses. That's why you take it a positive point that you procure this book immediately.